Hey, this is Brock Lemire's. We're continuing our study of embedded systems design. We have switched over to the programming language C for this chapter, and we're looking at the timer system on the MSP430 FR2355. In this video, we're going to look at a timer capture. Okay, so remember, let's talk about what a capture is. First of all, the capture compare registers, CCRs, have two functions. One is compare mode, where you put a value in here and it will set a flag when the timer reaches that value. The other mode is called capture mode. And what it does is when an event happens, external event, then it grabs the value of the counter and stores it in here. And so it's used to measure time between events. And so you can trigger the external event on when to grab the timer value using either an input to the MCU, so it can be a pin on the device, or you can also route, some MCUs have it connected up to other things internally, or you can actually trigger it with software. And so what we're gonna do is we're gonna trigger a capture on software, and we'll watch how we grab the value of this. When you put it into capture mode, you use this bit called CAP, which is in the configuration register, and you put it into capture mode. By default, these come out of reset in compare mode. Yeah, and so let's take a look at the register here, the configuration register. So you have the capture control register for each of the registers in the timer system, and you're gonna have the CM bit, which is the capture mode, and what you wanna do here is if you're gonna do a software, you are gonna use software to trigger a capture, we put this into 1-0, which means capture on, or excuse me, 1-1, and that means capture on both edges. And then what we do is we use the capture compare input select to, instead of choosing like these two signals that can come from, you know, a pin or an internal device or something, internal peripheral, we use ground and VCC to create an edge. So what we do is we set the most significant bit of CCIS to a 1, and then we can have some event like toggle the least significant bit. So as this goes from a 0 to a 1, it changes the input line from a ground to a VCC, then back to ground, then VCC, ground, VCC. So it's creating edges. And that means that if it's sensitive to both edges, we're good. It actually creates the edges in software. So we're gonna do that. Okay, so the other thing that we do here is the cap bit is what puts it into capture mode, so we have to set that. And then you have all the other flags and everything set up right here. But what we're gonna do is, let's do an example where we're not gonna use an interrupt from the compare system or the capture system. What we're gonna do instead is let's set the system up to have a pretty slow clock. So let's do a clock and then divide it by 8. And then what we'll do is we'll just put this in continuous mode, and then we'll continually fire a capture. And so we'll just like use software to like fire a capture and grab the value, and then fire a capture, grab the value. And what we'll do is we'll use a breakpoint, and we'll watch the value of the timer system get captured into here. So we need some way to like trigger the capture. So why don't we set it up as a button press? So if we press switch 1 on the launchpad board, let's have that set up fire an interrupt and do an interrupt service routine. And then the interrupt service routine will handle this thing of switching the CCIS bits to force a software capture. Okay. All right. When this happens, I will say that the captures can have their own interrupt vector table, vector address. They're the same flags and same vector locations as are used by the compares. And so I highlight this right now, but for this example, we're not going to use it. Okay, so let's fire this up and get rocking here. Okay, so here we go. So we're going to fire up, boom, boom. Fire a new CCS project. So let's call this C timers capture, and I'll call it software to let us know that we're triggering this with software. Okay, so I'm going to finish that, buddy. And a lot of this example program is going to be setting up all the other stuff, because we have to set up the peripherals, right? So not peripherals, we got to set up the ports. So a lot of this code is going to be to set up the interrupts for the switch 1. So let's set up the ports. Okay, so should we do LED? Let's do LED. So let's have the button, every time you press a button, it toggles LED 1, just because then we know we've pressed the button, even though it'll be obvious So let's do port 1 dir, and let's do a bit set using a bitwise OR with bit 0, and that is set P1 0 to output, and that's LED 1. Okay, and then we'll do P1 out, and we'll clear it. So I'm going to go ampersand equal tilde, and we'll do bit 0 there. So we'll do set or clear P1 0 initially. That's LED 1. Okay, so then now we got to set up the push button switch. So remember that port 4-bit 1 is where SW1 is. So input, so this is switch 1. So that's the button on the launchpad board. And we're going to set this up to receive a button press, and then we'll have it trigger an interrupt. Okay, so let's do we got to clear this. So I'm going to do P4 dir, and I'm going to clear ampersand equals tilde. And I'm going to do that with a mask called bit 1, and then that is what gets us as an input. Since it's connected to a single pole, single throw switch, we need a way, and the switch is connected to ground. It can pull a 0, but it can't drive a 1. So what we're going to do is use an internal pull up to create the 1 status when the switch is open. So I'm going to do let's see, this is in port 4 resistor enable, and I'm going to set bit 1. So that's going to be enable resistor on P4 bit 1. And now we need to set the polarity of it. So I do that. What is this? What am I doing? Port 4. So then I need to set the polarity. So I do that in the port 4 out, which it's now in its secondary function. And I'm going to set the bit. And so I again use bit 1. And this makes resistor a pull up. Okay, and then since we're going to do a interrupt, we want to set the sensitivity to be either low to high or high to low. So let's do port 4 IES. That's the interrupt edge sensitivity, and I'm going to set this bit. And the reason is that I'm going to set IRQ sensitivity to high to low. And that's because when the button's not pressed, it's at a 1 by the pull-up resistor. When you press the button, it goes to a 0. So I want, as soon as I press the button, I want that to trigger the interrupt. So the only thing left to do for the digital I/O is to turn it on. So I need to do a clear on PM5CTL0. I'm going to clear, so I do bitwise and equal tilde, and the bit mask is PM5CTL0. Okay, so this is turn on digital I/O. All right, so that looks fine. We'll come back and get typos if we mess that up. The next thing we need to do is let's set up the interrupts for that while we have ports on our mind here. So let us set up port IRQ. And how do we do this? So first and foremost, we are going to do we're going to go into port 4 interrupt enable register. We're going to set a bit. So I'm going to do a bitwise OR with bit 1. So this is going to be local enable for port 4 bit 1. Okay, so I went ahead and set that bit, and now in reality we're done, okay, with the local enable, because we can go ahead and go and at this point we can do the maskable interrupts, okay, enabled maskable interrupts. So I go ahead and I do enable interrupt, and then I'm waiting for purple. Oh, give me purple. So this is going to be enable maskable IRQs. And so you might say, well, why aren't we using the capture? And we are using the capture. We're just not going to have the capture trigger an interrupt. When it captures, it will raise its flag. And we actually will never even look at the flag. We really don't care. All we're going to do is look at the value in the capture register in the debugger when we do this. And so that's why the only interrupt I'm using is the switch 1. So I got that. Let's go ahead and clear our flag. So I'm going to go into what is it here? Let's see. I'm going to go to port 4 for IFG register, configuration register, and I want to clear. So I'm going to go ampersand equal tilde. I want to clear bit 1, and this is going to be clear flag. Okay. All right. So now that is my interrupt. So I should be good to go there. And now we got to set up the timer. So set up timer, and think about the timer. We got to turn the timer on, to begin with, right? So let's write to TB clear first. Write a 1 to that to clear it. I'm gonna go TB0 CTL, and I want to do a bitwise OR with a mask on TB clear. Okay, so that's gonna reset timer. And then we are essentially done. So, oh no, we got to put it in continuous mode. So then we got to go to TB0 CTL, and I got to set that into continuous mode. So I'm going to go bitwise OR with MC __ continuous. Okay, so then put into continuous mode. All right, so I got that. So if I look at my timer, it's like it's in continuous mode. I'm going to leave it at 16 bits. And now I'm ready to go choose my clock source. So let's now go TB0 CTL, and I want to go ahead and do a bitwise OR, and I'm going to choose a clock. So I want to go TB __ TB SSEL __ a clock. That's going to choose a clock. And then the only other thing we want to do is we want to do a divide by 8. And it turns out I went and looked up this mask, and it's TB0 CTL. And what I do is I do a bitwise OR with this bit mask. It's actually ID __ 8. So this mask right here will set the 2 bits of ID. So it's like a 0011 0000. So that mask is good. So I'm going to do a div by 8 in prescaler. Okay. So now let's sit here for a second and think about what's going on. I've got the timers going. I've got the clock sources. I'm running with a really slow clock, and so we'll be able to see this in count. Now let's think about the capture register. So let's put this into cap mode. So we got to put this into cap mode. So I'm going to do setup capture. And first thing I want to do is I want to go into the TB0 CCTL0 register. This is the configuration register for CCR0, and I'm going to do a bit set on the cap bit. So I'm going to go cap. Okay, so this is going to be put into capture mode, and more importantly, it's put CCR0 into capture mode. So it's only configuring that one register. Okay. Then the other thing we want to do is we want to put this in its sensitivity to both edges. So the signal that we choose is going to be sensitive to both edges, and that's how we can move back and forth in this configuration. We can move back and forth between ground and VCC, and that'll cause the trigger. And so we need to go into the CM thing and put it into this mode, capture on both edges. So to do that, I go into TB0 CCTL0, and what I'm going to do is I'm going to do another bitwise OR to set this bit. And the mask on this is actually called CM __ both. So this is sensitive to both edges. And I mean, these masks are awesome. Somebody went through and made all these awesome masks. And thank you for that. Okay, the other thing that we want to do though is we want to set the initial signal, the initial input signal, to be CCIS is equal to ground. And that way, when I push the button, I'm going to change it to VCC, and that'll create an edge on the signal, and it'll cause the thing to capture. So go ahead and do TB0 CCTL, and I'm going to set a bit using a bitwise OR. And here's this mask. Check this mask out. CCIS __ GND. I mean, these masks are put input level at ground. Capture input level at ground. Okay, this is fantastic. Okay, this is fantastic. And so now we're sitting here, we're ready to, I mean, it's ready to go. But let's do a variable where we go like int, and then let's call what I captured. Let's go ahead and do equals 0. Okay, and that is just going to, I initialize this thing, and then what I'll do is every time that I press the switch, I'll take the value Actually, it doesn't even matter, does it? All we care about is what it looks like. But yeah, let's do that. Let's make a variable, and we might assign to it, we might not. We will. It sounds like we're making stuff up here. So while one, and I'm just gonna spin. Okay, so I'm just spinning, no big deal. All right, now here's the trick though, is all I've done is turn this whole thing on. I haven't actually done anything cool yet. So it's time to leave the main program and go down and do my interrupt service routines. So let's go down here and we'll do, these are ISRs, and boom. And now we're ready to do something which is kind of cool. We are ready to do an interrupt, but the interrupt is for the switch, because in the switch is where I'm going to force trigger the capture using software. So I'm actually going to do pound pragma, and that tells the compiler, hey, buddy, get ready. I am about to initialize the vector address for the, I'm going to initialize it for the port 4 vector. And so if you look at what the port 4 vector is, it's, oh, sorry, it's this port, it's port 4, even 4 vector. Okay, so very descriptive. And then we're going to go underscore interrupt, and then we are going to be able to go void, and now we can go ISR, and this is going to be it's actually the switch 1. It's actually port 4 underscore switch 1 ISR. Okay, so it's, yeah, whatever, or whatever. Not whatever, that's what we're doing. So just to be clear, we're writing an interrupt service routine for the switch, and then in the switch is where we're actually going to do our cool force trigger. Okay, so I'm here, and now what do I want to do here? So I got to set up my interrupt service routine. So let's do the interrupt service routine. So here somebody has pressed the switch. What do I want to do? First of all, let's toggle the LED. So let's do P1 out, and let's toggle it. So then I'm going to do bit 0. So this is going to be toggle LED, and that'll prove that we pressed the button. And then what I'm going to do is I am going to force a capture. And I'm going to do that by doing the following. So we are going to go into the TB0 CCTL0 register, and I am actually going to toggle this bit, CCIS0. And this is going to be switch back and, back and forth between ground and VCC. This instruction right here is doing the following. We have set this to ground in the initialization, and that set the most significant bit of the CCIS fields. And I'm going to toggle this least significant bit, and that's going to allow me to take the input signal that forces the capture to go back and forth, ground, VCC, ground, VCC, ground, VCC. And that's the software trigger. So that is what's going to force it to cause a capture. And we'll see the timer value actually go into the capture compare register 0. Okay, so then we have that. All right, so life is good. And now we're sitting here thinking about this, and it's like, should we store the value? Yeah, why not? Let's just see if we can put that into this little buddy. And what am I storing? Well, it's the capture register itself. It's TB0 CCR0. And so we'll not only see the value of the timer go into TB0 CCR0, we should see it also go into this variable called what I captured. So then we'll store off captured value, and we'll remember to turn optimization off just in case it tries to get after us. Okay, so now that's the interrupt service routine. So guess what? It's an interrupt service routine. You got to clear that flag, buddy, or you're going to fire again. But what flag is it? It's the port 4 bit 1 interrupt flag. So I got to come in here and I got to clear this thing. Okay, so I'm going to clear that, and I should put port 4 bit 1 flag. Okay, how's this feel? Well, let's go ahead and save this. Now this is a ton of typing, so holy cow, I can't imagine how many typos. So bear with me while I fix up all the typos. Typo number 1. Let's go see what this is. PM4. Yeah, you know PM4? Who said it was? I said PM5, but I typed PM4. And then line 47, what I captured is undefined. Oh, geez, sorry. I have a variable that I'm trying to assign to in the interrupt service routine, but I declared it within the main function. This is going to be a global variable. So My bad. Let's pop that buddy out there. Okay, so let's go ahead and try that. And then let's go ahead and download this and see if we made it. And okay, looks like we're good to go here. And let's see. All right, so now let's think about what we're doing. So what I really want to look at here is the registers, right? So I want to come into the register viewer. So let's go into register, and I want to, oh boy, it popped me out. Let me pull this back over. There we go. Okay. So I'm going into my register viewer, and I want to go down into the timer system. So you go down to TB0, and here's all these control registers, right? So it's control register 0, 1, 2. But here's my output of my counter, TB0R, okay? And then here's the capture register. And so what I'm going to do is I'm going to run this, and when I push the button, it is going to update CCR0. But I need to put a breakpoint in the interrupt service routine so that the debugger can actually get the values and I can see them. If I just hit the button, the debugger only runs when you're suspended. So I'm going to put this at the bottom of the interrupt service routine. And what's going to happen is I'm going to run, and then I'm going to hit switch 1, and it's going to trigger, and it's going to come down here, and I'll see the debugger update, and you'll see the value of the timer. You'll see CCR0 be updated with that, and then the timer will continue to run. So then I can hit run again and get a new value. So let's just do it. Okay, so I got the board here. I'm going to run. Okay, so I'm going to hit the button, and the LED changed. So that told me that I toggled it. But look at what happened. I was able to see the register, the timer, and I saw it also get captured into CCR0. So it worked. Okay, so I'm going to go ahead, and now the timer's still running. So I'm going to hit resume and hit the button, and look at it. It's another number. And then let's do it again. So run and hit it, and the LED is toggling. And look at it. It's going up, but it's not hauling, right? I mean, it's going up by a couple thousand hex each time after a couple seconds. And that's because I have the counter clock running so slow. So it's only, it's just running slow. It's using the divided 8 over, it's using a 4 kilohertz clock. Okay, so there it is. So it's been sitting there for a while. I'm gonna hit run, and boom. Okay, nice. Now the other question is interesting because it says, I did this assignment to what I captured, this global variable. And you're like, where's that at? And so even with optimization off, the CCS doesn't show it for some reason. But I just happen to know where it is. It's at the beginning of data memory. And that's because it's a global variable. So I declared it out here, and it turns out that it puts it at the beginning of data memory. And I tried this with optimization on and off, and it put it in the same place. But take a look at this. So 2000 is the beginning of data memory. This is the same as like going in and going in assembly and going dot data and then dot short. No, not dot, sorry, dot space, and then initializing it to 0. But look at the value that's in here. So now what's interesting is if I go back to register viewer, I want to see what's happening. You notice that they're the same value. Watch as I do it now. I'm going to hit run, and then I'm going to hit the button. And look at what happened. The timer value was 65 dB. It got captured into the capture register, and then it also got assigned to what I captured. So I was able to actually get this value into a variable. So let's do it a couple times. So run, press the button, check it out, 72B9. I'll take that, run, press the button, 80D4, and I'm capturing it and I'm storing it off as a variable. So now I can sit here and I can measure time. And you're like, how are you measuring time? Well, watch this. Let's do a fresh one. So boom, I'm at 8D56. I want to know how much time is transpiring between the press I just did and the press I'm about to do now. So watch this. I'm going to hit run. The timer's still running, and I go boom, and I press it. So now I have B0A2. So all I got to do is subtract those two numbers. So B0A2 minus whatever the last one was, I already forgot. And then I take that and I just multiply it by, that's the number of counts that transpired between button presses, and I multiply it by 1/4 kilohertz for the clock period, and I can measure time in between presses. And that's cool. So that's what you use timer captures for. So, wow, holy cow, you did it. Nice job. That's it. So that's timer captures. We did a whole lot of typing there, but hopefully it made sense. So anyway, so always support my channel by subscribing, and see you.